This video is about basic sets. So the first thing we're going to do is talk about the two methods for identifying a set. The first thing that we could do to show a set would be simply to list the items in it. For example, the numbers 1, 2, 3. So this is actually a set that lists the numbers 1, 2, and 3. Set builder notation is where we identify by saying it's the set of all. If this is set A, it's the set of all A such that A is an element of the first 3 counting numbers. Okay, let me go again and repeat. This is the set, this is read, the set of all A, and this vertical line is read such that A is an element of, it's like a pitchfork without the handle, or a sideways E, the first 3 counting numbers. So we identify this. So if this went on and on forever, you could say the set of all A such that A is an element of the counting numbers, because we wouldn't just be talking about the first 3. If we add the ellipses or the and so on dots, that means it goes on and on forever. Okay. Now, within sets, we can have something called a one-to-one correspondence. And sometimes it's valuable for us to be able to identify, oh, excuse me, oh, to identify all the possible one-to-one correspondences between these particular two sets. So we would start out with each of the elements in the first set. Then if I'm going to pair each of these with these, then what are my options to pair 1 with? Well, I can pair 1 with what? A, 1 with B, 1 with C. I could pair 2 with A, B, C. I could pair 3 with A, B, and C. So basically, if I'm looking at this, here are my one-to-one correspondences, so I could pair 1 with A, 1 with B, 1 with C. Then I could pair 2 with A, 2 with B, 2 with C. I could pair 3 with A, 3 with B, and 3 with C. And there are all the different possible one-to-one correspondences that I could have. So I have how many different? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, I also want to look at something called a Venn diagram when we talk about sets. And a Venn diagram starts out with the big rectangle, which represents the universal set. Okay? And the universal set would represent everything that you're talking about. Now, it doesn't matter what the items are that would be an element of A in this particular instance. So everything that's in A would be represented inside this circle. Everything that's not in A is outside the circle. So inside the circle would be A itself, and outside the circle would be read a complement. The bar over the top of it means it's a complement. And if I add the two elements, the elements in both of the sets together, then I'm going to get the universal set, okay? Because I would get the set of everything that's in there. Now, history note, you might want to look up and see who Venn was and see what all he actually did. And that's it for real basic set info.